Good evening, ladies and gentlemen. Gianluca Massi speaking on the behalf of the Virtual Telescope project. And it is such a privilege for me to be live tonight, going to share with you something very special. We are ready to show you no less than the famous James Webb Space Telescope, one of the most important technological instruments ever made by humans out there in space while it is traveling to its final destination, ready to start its mission and ready to unveil something incredible, a new, very likely promising a lot of new science and improving our understanding of the universe. Before I start showing images live of the James Webb Space Telescope captured from space, I really would like to thank the technological partners of the Virtual Telescope project. They are Unitron Italia Instruments, Software Bisq, C-Web, Bader Planetarium, Santa Barbara Instruments Group and Planewave Instruments. That said, I really would like to start taking images and then I will tell you a bit more about the James Webb Space Telescope. And the first thing to do for me is just to share with you the live console from the telescope. This is basically the system, the software controlling our robotic telescope. Perhaps some of you have been with us in the past and they know what we do, that is sharing the sky live like if you were personally at the telescope. This is the software controlling our robotic telescope. While I'm speaking, I am in Rome, Italy, and the telescope is about 100 kilometers south of Rome. So I am in Rome, but the telescope is not here. It is quite far from me, but the blessed technology is making possible for us to have fun and hopefully to see the James Webb Space Telescope as a dot of light while it is moving against the starry background, reaching its final position from where it will start revolutionizing our knowledge, our idea of the universe. But I really want to point the object. As you can see here, we have the stars shining above our observatory in central Italy. By the way, I apologize if yesterday I could not honor the promise we did to show the James Webb Space Telescope because there were plenty of clouds up there, but tonight weather is much better. And you can see famous constellations here. Among them you can very likely recognize Orion. You can also recognize Taurus, that is the bull, and many more objects. And they are constellations, as I told you, but somewhere there we have also the James Webb Space Telescope. And here it is. You can recognize here its name. I just click on it to make sure you understand where the James Webb Space Telescope is right now. I'm going to ask my system to show it. Here it is. And I also want to make clear what you are seeing. Where you see the yellow circle, you are seeing where the telescope is pointing now. Where you see the red circle is your destination. As you can see, the telescope is now looking somewhere in the Orion constellation. And just to give you an idea about what we are seeing, I will take a very quick image here. Let me try. Here it is, showing something very famous in Orion, that is the Orion Nebula. Let me see. Here it is. Just to make sure that you understand that we are really showing astronomical items, astronomical objects, like in this case. That said, I really want to move to the James Webb Space Telescope. Let me take another quick image here, just to show you a larger field of view and the beauty of this nebula. I find interesting to spot such a cosmic treasure before looking for the James Webb Space Telescope, just to imagine that they will be these astronomical objects ready to show something never seen before, thanks to the power of this new space telescope. That is, now I will say goodbye to the Orion Nebula, and I will ask our system to go and slew just to image the James Webb Space Telescope. Please understand, while I'm speaking, this object is more than 1 million kilometers away. We will check for the distance in this very moment. There is also a website from NASA telling this kind of information. But it is interesting to see that there are, you can see even some interesting satellites crossing the field of view, like this vertical line here. Very likely this is the satellite, of course. And then I want to prepare our system to image. Okay. I will ask now the system to track. Okay. Please understand, now I need to set up a few things and then I will tell you about what is happening. I think we are almost done. Just checking, doing some preliminary things. I really wanted to share with you even this very moment, just to make sure that you can really enjoy this part of the adventure, that is pointing the real object, like if you were at the observatory. I'm just refining the pointing. We should be almost there. And now I will start taking an image. Okay. And then I will tell you what is happening so that everyone here can easily understand what we are doing. Okay, I should be there more or less. So friends, what we are doing? You know, we want to see the James Webb Space Telescope. The telescope left our planet on the Christmas Day, so it has been out there for a while now. So it is somewhere in our solar system, not very far, but it is already a bit more than 1 million kilometers from us. So it is almost 3 times the average lunar distance. So it is not actually close, but we know what it is because we know its path in space, and this is why we are able to ask to our telescope to point where the James Webb Telescope is. So I just asked it to our ground telescope to point the exact position in the sky where the James Webb Space Telescope is, and the telescope, my telescope, the one we have on planet Earth, has just done this. But if you look here, I think you can easily recognize that you see a number of dotted lights, and at the first glance you really don't understand which is James Webb Space Telescope, because while it is more or less as large as a tennis court, it is so far that it is a dotted light for us, and the only possibility we have to recognize it quite easily is just to spot its motion against the starry background, and this is what our telescope is actually doing. So I asked my telescope to point where James Webb Telescope is supposed to be, and then I asked to my telescope to track James Webb Space Telescope across the stars. And now it is taking a long exposure. On the upper left you can see exposing light, 52 seconds, 50 seconds left, and we are waiting for that countdown going to 0. At that point the very sensitive camera we have on the telescope will download its image, and we should be able to recognize where the James Webb Space Telescope is, noting something very simple but very special. But I really don't want to tell more because I really would love to have you just looking at this. We need to wait about 10 seconds plus a few more seconds to have the signal generated in our digital camera downloaded and converted, digitized and made available to our computer. Something happening now, and let's see if we see something here. We can perhaps understand it is a James Webb Telescope or not. Perhaps it should be this dot of light here. How can you bet who is James Webb here? Let me do this. If you look here, you see that all the stars are apparently looking as very little, almost vertical trails, with the only exception of this dot of light, friends. Why? Because as I told you, our ground telescope, the one belonging to the Virtual Telescope project, has been asked to point and track James Webb Space Telescope while it is moving out there. So the telescope is just tracking it very well while the stars are apparently shifting on the background. And this is why I'm pretty sure that this dot of light is James Webb. Soon I will try again with another image. We have 100 seconds to wait, and meantime I will tell you something about this telescope. We have been waiting to have James Webb Space Telescope launched for many years. Even soon after the other legendary space telescope, the Hubble, was launched about 30 years ago, we started talking about the next generation space telescope. This is why James Webb Telescope was called at the beginning, but for a number of reasons its launch was delayed, and we saw the James Webb Space Telescope launched just last Christmas, But we have a lot of expectations because this telescope is definitely much more powerful, and it is just going to take the legacy of the Hubble Space Telescope and pushing our knowledge to a further, much more higher level, my friends. So the next years will be very exciting, but it will take a few weeks to James Webb Space Telescope to reach its position, to do some tests, to prepare for its own adventure. And if you have seen the NASA Space Webb Telescope, and I suggest you to have a look there, you have seen that almost every day after the James Webb Space Telescope was launched, there was something happening. There were many things to be done, and some deployment, phases, and that included, for example, the sun shield, just protecting this very sensitive telescope from the sunlight and the heat coming from the sun, because James Webb is going to work in the infrared, and if you want a nice infrared telescope, you have to be sure that your instrument is very well protected from the heat from the infrared coming from the sun. Then you also had the secondary mirror going to its position, and then also the primary mirror wings succeeded deploying these last couple of days the last one a few hours ago. So we are observing James Webb Space Telescope after a number of operations, now providing the shape of a real telescope. Now we can call James Webb a telescope, my friends, and I can easily confirm now that this is James Webb Space Telescope. But if you don't mind, I would like to do this. I switch again to my quick imaging system. I want to put James Webb in the very center. I'm truly amazed and excited to see this dot of light, knowing it is James Webb Space Telescope, my friends. I hope you can understand this and that this can make you happy and excited as I am, my friends. Now we need to check to center. It should be this one. Let me see if I can do a better work. Just putting this dot of light here, more closer to the crosshair. I really cannot tell you how excited I am to have the opportunity to do this together with you. Okay. We are putting our telescope almost to the very center of the field of view. I would like to have you stopping for a while and thinking that thanks to a telescope on our planet, we are spotting a technological instrument, the most technological telescope ever made, just while it is traveling to its final destination, preparing a new adventure and going to help us a lot investigating and unveiling the nature of the universe where we live. I think now that we can be happy, and I will ask the system to take a long exposure. So I told you that after its launch, James Webb Space Telescope has done a lot of things, just slowly taking its shape, just preparing the sun shields, protecting it from the direct light from the sun and from the solar heat. Because as I told you, one of the most important differences between Hubble Space Telescope and James Webb Space Telescope is that the latter, the James Webb, is going to work at the infrared wavelength. This is very important if you want to see very far in the universe that is very back in time. You really need to shift from the visible light to the infrared because of the redshift, just shifting the light to the red side and even more to the infrared side. So this is why James Webb Space Telescope will work with the infrared radiation, because it is in the infrared that we will have the best opportunities to observe the young universe when universe was very young, that is very far from the modern age, so very far even in distance, and from a distance from where we are receiving redshifted light. That is why you are working in red and even more red, that is infrared. This is very important because, as I told you, if you want to study, if you want to unveil the very first phases of the universe, the cosmic evolution, you have to look very far in space, that is very back in time, and from those very far regions you are basically receiving infrared radiations, to the point that if you want to go even farthest, you have to switch to microwave This is the cosmic microwave radiation, for example, just for those having some familiarity with the cosmology. And this will help us also, James Webb Space Telescope, thanks to the choice to use infrared radiation. It will help also understanding the formation of planetary systems, and even it will help, and it will be extremely important to understand about the atmospheres of extrasolar planets. And this is a very precious step to understand, perhaps to bet about the environment of a given extrasolar planet, my friends. So I cannot tell you how important James Webb will be. And it is even much more powerful than Hubble. Consider that the mirror used with Hubble was about 2.5 meters in diameter, while here we have a 6.5 meters diameter. So it is incredibly larger, but quite incredibly, the James Webb Telescope is much more lighter than Hubble Space Telescope. The magic of technology. Now here we have again an image, and perhaps I can show you pretty well. Here it is, my friends, James Webb Space Telescope. I'm truly excited. Again, I tell you, we are tracking James Webb Space Telescope during the 3 minutes we are using to collect light from space. This is why after the image is shown, you see James Webb as a dot of light, because it has been tracked, kept in the very center of the crosshair, while the stars on the background are leaving those little trails. I find all this extremely beautiful. And I hope you will understand my excitement, because showing such a really a gem is not happening every night, every day. And not all telescopes are able to share live what we are doing tonight. By the way, this is why if you want to support the Virtual Telescope project, if you like what we are doing and want to see more, and in particular if you want to keep us alive, consider the possibility to support us by a donation. If you want, just visit www.virtualtelescope.eu and just decide if our project is worth your support. I'm just waiting for another image. It will take a bit more than 60 seconds to be collected, a few more seconds to be digitized and shown, but meantime, here it is, our beautiful technological James Webb Space Telescope, named after the NASA administrator who worked during the Apollo legendary missions. And I want to check how far in this very moment we are with our James Webb. I'm just going to do this calculation now. Or better, let's use the NASA website, which is extremely beautiful, by the way. If you visit the website web.nasa.gov, it will tell you many things, and in this very moment it is at about 1,080,000 kilometers from us. It is not just behind the corner. And look here how beautiful this object is now, my friends. Here it is. I'm so proud that once again the Virtual Telescope project is making possible to people worldwide to look up, to have fun, and seeing something so exclusive, really. And we have been doing this for a number of years, 2006, and we will do as long as we can. And this is why I said I kindly ask you, if you want to support us, to consider donating something to us. as everything you do, as you can see, is available for free. I want to thank the many hundred viewers connected right now, and I really hope that at least you can enjoy the experience like myself. These the little single pixels you see here are so-called thermal noise. They are typical with this kind of digital imaging devices, and this is why James Webb Space Telescope will stay very well protected from heat. And it is not on a simple orbit like Hubble Space Telescope. You know, Hubble Space Telescope is orbiting a few hundred kilometers above the Earth's surface, about 600 kilometers, a bit more than the International Space Station, sorry. And you know, years ago there were also some service mission from shuttle reaching the orbit of Hubble Space Telescope. But now this new amazing telescope, just taking the legacy of Hubble, that is James Webb Space Telescope, has been decided to put it in a very special place, the second Lagrangian point, a very special point of equilibrium in a system including, of course, the Sun, the Earth, and the telescope, of course. And this way, in the Lagrange the Lagrangian point number 2, both the Sun and the Earth will be on the same side. So provided you are protecting from the Sun, automatically you are protecting even from the Earth, this interference. So you are just to take care of one object, because from the Lagrangian point number 2 point of view, both the Earth and the Sun are in the same direction. I hope that I made this clear. While we are waiting here for a new image in about 9 seconds plus a few more seconds for digitizing the image, and you can really track this in real time. Look here, now you will see the dot of light, you know, to be James Webb, and the new trails of stars, just because it is slowly moving up there. I'm so happy that tonight weather is good, because we really wanted to show you these unique astronomical instruments after the huge exposure received by its launch on Christmas Day. When everything went well, I say that Santa does exist, and for astronomers, because we had such a beautiful gift from Santa Claus on Christmas Day. And I really hope that looking at that dot of light, that simple dot of light, will bring you emotion, just considering that what we are seeing as a mere dot of light is actually the most powerful probing instruments ready to help unveiling the universe we ever made in history. Sorry. So we are going to close this live feed in a few minutes, and I hope that you had fun looking up through our robotic telescope, and I strongly suggest you to keep an eye on the virtual telescope project, because in 10 days we will also observe the potentially hazardous asteroid going to come relatively close, but safely, of course, to our planet, that is 1994 PC1, the largest asteroid so far expected to come relatively close to our planet. And this live feed covering the asteroid closely approaching us is scheduled for January 18th. But visit www.virtualtelescope.eu to be sure to know where and when we will be live with the asteroid and many more other events, my friends. Just waiting for the new image to come, and again I invite you to consider that the beautiful telescope you have seen launched on Christmas Day is now about 1,100,000 kilometers from us, almost 3 times the lunar distance, okay? And now it is visible as a dot of light, and this is coming to you thanks to the Virtual Telescope project. How beautiful. So my friends, I really hope that you had some fun with us tonight with this 30 minutes of live feed covering James Webb Space Telescope. Of course, we want to wish the very best to this amazing, superb telescope, and we are really hoping to see it working without troubles, and we are looking forward to admire the beautiful images it will make for us, and enjoying the benefit of the amazing record-breaking discoveries just going to happen thanks to this super technological telescope, the James Webb Space Telescope. Again, I want to thank all of you for joining us tonight. If you want to support the Virtual Telescope project, just visit www.virtualtelescope.eu and consider donating something if you want. And I also want to thank the technological partners of the Virtual Telescope project: Unitron Italia Instruments, Software Bisq, C-Web, Santa Barbara Instruments Group, Planewave Instruments, and Bader Planetarium. That's all from Gianluca Masi, Virtual Telescope project, Rome, Italy. Take care, keep looking up, and consider exploring the sky and the universe thanks to the Virtual Telescope project. Goodbye.